Okay. Down. See, sulfuric acid, we have done two things. One, oleum strength, and second is double titration with sulfuric acid, right? So, how to prepare this H2SO4? Manufacturing of sulfuric acid. Right? So, there are large number of methods of preparation which you have already done in the lab of production of SO2. Sulfur dioxide can be obtained from iron pyrite. If you have learned the metallurgy part, iron pyrite, you're able to prepare SO2. Second, the catalytic hydrolysis is converted to SO3. Catalytic hydroxidation, SO2 is treated with oxygen to give, which is upon acidic hydrolysis, H2O in presence of H plus, you can able to prepare H2SO4. Is it clear? So these are the general method of preparation you have to learn. E25 is most acceptable surface catalyst for dehydration of H2SO4, right? You can download the chemical property. First chemical property is simple. With NOH, H2SO4, it is mentioned that NHSO4. It is only possible when this NaOH is a limiting reagent, right? Unless first reaction, if this NaHSO4 again react with this NaOH to Na2SO4. Now, sulfide ion, BaCl2 with H2SO4 is a displacement reaction. Chlorine is displayed by sulfide. BaCl2 with H2SO4 give BaSO4, whereas lead diacetate with H2SO4, lead sulfate precipitate and acetic acid. Okay. Affinity with water and clean property of oxidation. H2SO4 carbon. This is the most common reaction of carbon also. Sulfuric acid ke saath reaction. SO2 water and carbon dioxide. It's P4 red phosphorus. It gives H3PO. Red phosphorus is vigorously react with H2SO4. Large quantity of H2SO4 is added in phosphorus. Okay. It will give H3PO4, right? H2SO4 react also with H2S to give sulfur precipitate along with SO2. With HBr bromine gas release. With NaBr also bromine gas release. Clear? Clear? With bromine, Br minus to 0 and sulfur plus 6, it gain plus 4. So this is a redox reaction. So it can able to displace bromine from HBr and NaBr and it act as a reducing agent. Clear? It accept the electron. Any doubt? With HBr and sulfuric acid, HBr bromine ki oxidation -1 hai. When it is treated with H2O4, it is converted to Br2 -1 to 0. It loses 1 electron and sulfur plus 6 to SO2 plus 4 along with formation of these byproducts. Clear? Na2S2O3. Most important reaction of Na2S2O3 is reaction with iodine. Thiosulfate and iodine. This is known as iodometry. Used in the titration of knowing the value of iodine. Chlorine and iodine reaction are different. You can able to see that. Iodine is more common and chlorine is asked in last year. See. Iodine with Na2S2O3 to give NaI and Na2S4O6. Sodium disulfate reaction, right? Here, the oxidation state of iodine is 0 and -1. Except electron. Sulfur, you can see plus 2, plus 2.5, plus 2 plus 2.5. How many electron it accept? 0.5. The n factor of this is 1. N factor of this is 2. N factor of iodine is 2. Clear? So, if a solution consists of iodine, you can able to calculate the exact weight of iodine with the titration of this thiosulfate. Okay? For example, if this container consists of iodine, we titrate this iodine with Na2S2O3. Simple. But the only problem is that thiosulfate react only with iodine. So this reaction is used to calculate the weight of I2. सिंपल है, लेकिन इनडायरेक्ट आयोडोमेट्री हम बहुत सा कर लेते हैं. कैसे? मान लो हमारे पास एक सॉल्यूशन है जिसमें Cu2+ आए. Clear? And we are going to titrate this with Na2S2O3. So we know that Na2S2O3 will not react with Cu2+, isn't it? So what we do, we add Ki, excess of Ki. है ना? The excess of Ki के डालते ही Cu2+ and Ki react to form I2. Let's say I2 is produced and form in this reaction, and I2 reacts with the thiosulfate. If 40 milliequivalent of Na2SO3 is required, that means I2 present is 40 and Cu2 present is 40. So we can able to use indirect ideometry. Clear? So these two reactions are again very important. Rest all reaction you have learned. Clear? Any doubt? So apart from these reactions, complete this oxygen family with NCRT also. ठीक? Okay.